2024 is going to be a huge year when it comes to generative AI and new innovations. In my humble opinion, I am expecting a lot of techniques to make the inference more performant by using less resources so that it will be mass adoption for the generative AI tools, and most of the people would be able to run these large language models on commodity hardware easily. If you have been following my channel, you might have seen that while installing some of the models, sometimes they just fail out of memory errors or with other issues because simply my GPU is unable to cope with it. And as this is just a passion and I don't have any beefy systems or any funding from the corporate level, from the VC, so I don't have any high level GPUs, so it's very hard for me to run all of these models locally on my laptop or even my own servers. Even the cloud servers are very expensive to run. So that is where I think that projects like these Marlin are going to make a huge difference. In this video, I'm going to introduce you to this fabulous project which I think is the harbinger of what is about to come. The project Marlin, in very simple words, is a computational kernel specifically designed for inference in large language models. Marlin utilizes FP16 or half precision floating point and int4, which is 4-bit integer formats, to significantly speed up computations. Marlin can achieve nearly 4 times the speed of for processing batch sizes of 16 to 32 tokens, which is a substantial improvement in efficiency, near ideal as per Marlin. This project is open source, licensed under Apache 2, and primarily written in Python, CUDA, and C++. So this is something in very simple words. If you want to know a bit more detail as what exactly Marlin is in depth, then it is primarily a mixed auto-regression or AR linear kernel. The concept of mixed auto-regressive linear kernel is highly related to machine learning and statistical modeling, especially within the context of Gaussian processes and time series analysis. In order to understand what exactly this mixed AR linear kernel is, first we need to understand what Gaussian process is. A Gaussian process is a collection of random variables, any finite number of which have a joint Gaussian distribution. It's a powerful tool for non-parametric statistical modeling, often used in machine learning for regression and classification tasks. When we say regression, it simply means that predicting future values on the basis of past values, and classify means simply classifying in different categories. Another concept to know is kernel function. So when we say Gaussian processes, kernel function measures similarity or calculates the distance between data points in a transformed feature space. It's a core component that defines the shape and properties of Gaussian process. And then we have this autoregressive model or AR model, and this is a type of model used in time series forecasting. An autoregressive model predicts future values based on the past values. So it's a regression of the variable against itself at previous time steps. A linear kernel is one of the simplest kernel function. It is used in machine learning algos to calculate the linear relationship between two data points. So if we combine all of these concepts, including Gaussian process, kernel function, autoregressive model, and linear kernel, then we have this mixed autoregressive linear kernel that refers to this kernel function used within a Gaussian process framework that incorporates elements of an autoregressive model. So it means that this Marlin, which is a mixed autoregressive linear kernel, will be able to handle all of this time series data in a very performant way. I will drop the link to this Marlin in video's description. It is still an evolving project, so it is still not there in the production at the moment, I believe, but still you can install it. All you need to do is to git clone this repo and then go to within that repo and do pip install dot, and it will install it. Make sure that you have these prerequisites met, that numpy, pytorch, CUDA, and you should have NVIDIA's GPU and the higher one. And then you can do a bit more play around with it. I haven't tried it out, so please try it out. Let me know how it goes, because I'm just waiting for it to become a bit more mature, and then I will try it out. They have also posted some of the benchmarks, which I will leave the link and you can read through. All in all, very impressive. Really excited about this project. I think this is going to break some records out there. Let me know your thoughts. I hope that this was useful. If you like the content, please consider subscribing to the channel. And if you're already subscribed, please share it among your network. Thank you very much.